Hey guys, so in this video I'm going to be trying to make a radio, or at least the receiver, not an emitter. Making an emitter that makes radio waves where I can talk to and then like kind of send radio waves everywhere would be kind of complex. I really haven't done a lot of research about it, but I might do it in the future. Anyway, let's get into it. So fundamentally, radio waves, or the thing that goes between the radio station and your car, that carries the information that makes the music play. Those radio waves are the same thing as visible light, both electromagnetic waves. But there's one big difference between them, because you obviously can't see radio waves, and it is frequency. And frequency is also the reason that radio stations use radio waves specifically, okay? And that is energy, because frequency is proportional to energy. So if you have a light ray that has twice the frequency, it also has twice the energy needed to make it, okay? And so I want you to take a guess, right? How much bigger is the energy that it takes to make a ray of visible light compared to the energy that it takes to make a radio wave, okay? You might say it's 5, you might say it's 10, you might even say it's 100, okay? But no, the difference between a visible light ray and a radio wave is 400 million times that. So yeah, the reason now is pretty obvious. By the way, that's a similar difference than the energy of visible light compared to X-rays. So pretty strong. So now let's get into how you can really catch those radio waves and make you listen to music with them. So there's mainly two types of how radios work, okay? So the first one is FM, it stands for frequency modulated. And the second one is AM, it's amplitude modulated. I will explain AM now more because it's way simpler and it's what I'm gonna be making, right? So AM works like this. You have one thing called a carrier wave, okay? This then has a frequency of around, I think, 500,000 hertz to a million hertz and 600,000, something like that, okay? So from 0.5 megahertz to 1.5, around, right? And this is then what actually makes your radio station be your radio station, right? Because you actually do need to differentiate between it, because otherwise you'd like hear everything at once, and the music in that wouldn't really be enjoyable. So what you have then is one wave, okay? But obviously that's not music. So what you do is you add whatever you want to hear to that. So you can see really one wave with one singular frequency, but then in that is whatever you want to hear, right? And so then how you can pick this wave up and hear it is actually with a resonant circuit, okay? So a coil with a capacitor. And what this then does is, you can do this at home theoretically, put a voltage on that circuit somehow, okay, such that the current flows. But if you then put away that voltage, and theoretically if you have a resistance of 0, what will happen is the electricity will go one way through the inductor and then kind of the thing is that the inductor kind of carries the electricity in the sense that it can charge a capacitor, right? So the electricity is flowing, let's say this way, up here is an inductor and here's a capacitor, right? So the electricity is flowing there, and because it's an inductor or coil, right, it's gonna keep flowing and charge the capacitor at the bottom. But once this stops and the resistance kind of the capacitor goes too high, it uncharges. But that doesn't just stop as soon as the charges on both sides are, the same. It's just gonna keep going, right? And theoretically, with zero resistance, it can do this for infinitely long. So what you need to have in your circuit is a coil and a capacitor, right? And this is how the circuit will look, basically. So you have the antenna here, and this is gonna, kind of catch the radio waves and make a voltage that is kind of the same as the wave, right? And then in that, you're basically gonna filter out the one radio station wave with the one specific carrier frequency. And then this is just all for hearing that. So let's get into the build. So right here I graphed with the x-axis being the capacitance. The thing is, I have a few types of capacitors, but I didn't want to calculate all of this by hand. It would be too complicated and take too long, right? So I just graphed it right here with the y-axis here being the amount of turns, right? So I think I will, by the way, x is in picofarads. I think I will use something around the 680 marks. I will then use about 50. By the way, this is for the lower range, so I'll have to at least double it then to get to the higher frequencies. So for my coil, I will use this PVC pipe. Obviously it's too long, but I mean, I do have a saw, I can just cut it. So I calculated the minimum amount of turnings to be around 80, but that was pretty stupid because I mean I'll have to do more obviously, but I will just around triple that. So I'm gonna say about 180 I'm gonna say 150. Well, that isn't really triple, that isn't even double, but anyway, let's get to the thing, you know. Here it is. Isn't it beautiful? 150 turns. The thing is, what I calculated, what I used in the formula for the length is 0.7 millimeters per turn, right? But the thing is, this at 100 turns should have been then obviously 7 centimeters, right? So just 100 times that, but it was 8. The thing is, that is also pretty good because a higher distance is lower inductance, and lower inductance means higher frequency. The thing is, if I did just like that, I might not have reached the perfect frequency because I didn't do as many turns as I should have, as I needed, right? And the thing is, you might think, well, that isn't good because then I can't detect lower frequencies. I thought that at first too, but I mean, like, it starts at 0, right? It doesn't start at 78, it starts at 0. So that's just perfect that happened actually. Now the thing is, I will need to put some insulation or some enamel off of there, because then I can use the, something that conducts electricity like this, right? Such that I can tune the frequency. And for that, I'm gonna put on some polyurethane. I mean, this is just some color, but it contains polyurethane, so I guess it should be fine. But the thing is, I don't even know how to open this. Do I just do it like that? I think so, right? So I really don't know how I'm supposed to do this, but I guess I'm just gonna start somehow. Is this how it works? This feels wrong. I can't be doing it right. Oh well, how else am I supposed to do it? I don't know. Maybe I should find a way to stabilize this. This is weird, but it does work. Oh wait, this seems unstable. Nah! So it fell in the trash, so I guess I'll just hold it in my hand until it's dry. So here's the polyurethane painty thing. So how long does this take to dry? 1 hour. Okay, I guess I'll have to think of something again. I mean, you can say it doesn't work, right? So for the antenna, I'll be using this. Wait, did you really think I was gonna use that? No, I'm using that. So those are my headphones right there. And here's the cable. Oh, come on, focus, please. And wait, let me zoom in real quickly. Here's the cable. Oh, well, not the cable, the thing that you plug into. It's got 2 of these black stripes and 3 of these areas. And yes, there is a polarization to these. So there is a positive and negative thing. So wait, if there's 3 thingies, then it'll have to be, 3 possibilities times 2 is 6. So 6 for plugging in, and then times 2 because positive and negative counts 2. So I guess I'll have to go. Through 12 possibilities. So I guess, this is it. This is a fully functional radio right now. By the way, the reason I've got my multimeter here is not to supply any electricity, but it's because this has a particularly great grounding feature right here. And so what I will do is I will put the, cable thingy right here and then try to find the right connections. By the way, I turned the volume down on the headphones because I do not want to be blasted. Because, I mean, I measured the resistance of these headphones and they turned out to be pretty low. So, I'm not sure. It could be that I measured the resistance wrong, though. So, I guess the trying around starts pretty much now. Wait, first I will have to connect this. I wonder which frequency I will have to listen to, but I guess I will just do it as pick some random thing where I know the connection is existent, and just hear for some static, because if static appears, then it's looking good. I guess I'm still figuring this out, by the way. So I guess I will start now. But first I will test if there's even a connection there. Okay, I'm hearing nothing. Ooh! Disconnected. Hold on. So I didn't hear anything. Maybe it is because I am in my basement after all. But I guess I will try trying to detect the voltage. Maybe that will work. What? It's showing a voltage with spikes up to 11 millivolts. Damn. Yes, and they're constantly. That's great. So to show you I'm not tripping. So you can see the voltage is at 0. At least when I don't move the wires. See, when I move them, there is some magnetic fields that induce a tiny voltage, I guess. But what should happen right now is here. Wait, I think I connected this wrong. Oh god, this is hard to do with one hand. But I'm trying to show you that the voltage really peaks here. If I connect it, yes! Now you can see how the voltage is varying hugely, and it goes up to 40 millivolts. Please go up again. Is that connected? Yeah, it looks like that. Come on. Yeah, you see that 28? Before it went to 40, which is pretty insane. Wait, why was that just why is it negative? What? That's not supposed to happen. There's a little diode here. Huh? This is confusing to me. Like, that didn't happen at all before. Oh, now it isn't negative. Anyway, ignoring that, I'm just gonna show it to you like this. So, right now, I don't really care if it's negative or positive. So right now it shows nothing actually. Wait. So right here. Now, if I measure the voltage right here, it should... Nothing. Okay, that's fine. It just means that the connection here isn't very good, or if there isn't really any light in this frequency range. So let's put it to somewhere else where I can see that there's basically no coating on. And here. Oh, come on, you've gotta be... How is there no voltage at all?
This just keeps getting worse. It worked so perfectly fine at the beginning.
It's crazy that it shows a voltage when there isn't one. But I guess there are trace magnetic fields. Oh, no. Come on. Oh. Well, I see the reason. There's a stray cable here. Let me reconnect that. So now everything should be connected, I guess. Now let's try it again. I hope this shows a voltage this time. It should. It did before. Yeah, that's looking good. No, it isn't. Ah, come on, now the diode is disconnected. This can't be real. Okay, now everything has to be connected, right? Yeah, it appears to be that way. You've got to show voltage now. Oh, yeah, no. I'm actually gonna start raging. This is very confusing.
Oh my god.
Okay, I'm tripping. The moment I turned off the camera and tested it on my own, it worked fine. I have to show you this, okay? I'm just gonna hold this with my shoulder to avoid any trouble with the capacitor bank. Oh, come on! I hope the connection is just bad right here. Let's check it now. Hey! Can you see how the voltage is varying? You might see me talk weird because I don't want to make too much vibrations to cause anything to go bad. So now you've seen it. The voltage does vary. And in theory, if this could refresh quick enough, I could just make a sound based off of the voltage spikes and, you know, but, well, I mean, this is basically what this is, right? This just takes the voltage and makes you hear that. And I think I know what the problem is. This is just not sensitive enough. Maybe I will have to find something that you can plug directly into your ears, because I mean, then the distance between the emitter and your ears is smaller, so I guess the voltage required is smaller too? Well, I guess I'll see what I can do. So I'm in my room now in hopes of getting a better connection. But this is really unsettling. The antenna is just standing there without any structural support. Oh my god, something crazy just happened. As you can see, I'm trying to hold my phone between my chin, in my chin, under my chin. But whenever I press this connection and the one on the back here, you can see the voltage spiked to, come on, 500, almost 600 millivolts. That is absolutely insane. Do you know how it is to hold my camera like that? Are you even seeing it properly? Are you seeing my chin? I hope not. But that's 570 millivolts. That's so much huger than before. I'm actually having hope this is gonna work. So let's see if it'll work this time with, I think if you had 20 millivolts before, around 300 times that max. No, wait, 30 times. I'm sorry. That was a typo. Wait, not typo. What am I talking about? I'm gonna just start. By the way, the antenna is still there. I just know this is gonna fall over eventually. But I'm too lazy to kind of tape it onto the wall or something like that. I mean, that isn't a particularly good solution too. But yeah. Thing is, I have to, as you've seen, I have to also press on the thing that's pressing on the coil. You know what I'm talking about. You know, the thing with which you adjust the amount of turns. Guess I'll have to press on that too. Wait, I forgot how to, I think these two. I'm hearing absolutely nothing. Okay, but I still can try around with finding the correct connections. What? Do you know what I just found? If I press on there, the voltage goes to around 40 millivolts. If I stop pressing, it jumps to 350. What the hell is going on here? This is confusing. because pressing on it would make me believe that the resistance is lower. I guess I will try it like this now. The hairy thing is. Wait. You know what I just heard? This is absolutely horrible. But I did hear something. You know what was really amazing? It only happened when I touched the cables. Which is pretty confusing. Because why would touching the cables make a noise? Maybe it isn't touching the cables. Maybe it's kind of shorting the electricity thing, you know? That is really confusing. I can't do this anymore. What's very weird now is the fact that I'm not measuring any voltage between the ground and antenna. I can't do this anymore. You know what I just remembered? I have this radio at home that you can charge by, you know, spinning the generator. And now I want to see, is there even any AM stations in my region? Can you even detect it with such advanced technology? Let me generate. I don't know what that was. What the hell am I hearing? This is not German. Can somebody tell me what kind of language that was? It's absolutely insane. I'm picking up stuff from like hundreds of kilometers away. Maybe like Czech.
Под видом курьеров просят продиктовать код из СМС. Якобы для подтверждения адреса. Но на деле этот код открывает доступ к банковским операторам.
This also wasn't German Austrian. Wait. Music. Okay, so I guess the problem is the radio and not the lack of, you know, AM frequency towers. I'm too tired for this shit. I'm gonna finish this tomorrow. So I did get some motivation again, and I figured something out. By the way, I'm using some of these kind of, my god, I keep on forgetting words, these hearing things, you know, these earbuds. Yeah, I mean, that's kind of it, right? And if I connect it with the front, with the antenna and the circuit, and the ground with it right here, then every time I touch, I hear a little crackling sound. And this means, this at least means that there's enough voltage for a sound to be made. At least during a quick discharge. Maybe then if I move if I adjust the frequency. Oh, no way, there's a goddamn fly. But at least what this at least tells me is there is some electricity here, right? And kind of enough to hear. So I think I will buy some of these little piezoelectric airy things that are super sensitive to sound. Oh, I'm outside now, but the table doesn't seem to be high enough because this should just be lying there so that I can adjust the frequency well. So it looks pretty curved, but I mean, it does work, I guess. Now we'll just have to get my headphones. Oh wait, no, before that I can actually measure the voltage. Yeah, I guess I won't be measuring voltage. I mean, I just put a new battery in a week ago, but I mean, I guess it's empty already. Pretty annoying. Yeah, I got nothing. Wait, why do it look so devious? So, partial success. I was able to build the radio. I mean, that was all of the success. I mean, building this was really a pain in the ass, to be honest. But the problem that I had with just not being able to hear that could very, very easily be fixed by just, buying one of those piezoelectric air thingies, right, that are more sensitive and more easily to emit sound than the regular ones. I mean, makes sense though. Yeah, but whatever, I'm not really that disappointed and I do kind of want to get this video out. I mean, I've got other stuff to do and I really want to start my nitric acid video. I think that will be my next. It doesn't have to be though. Yeah. If you really expected a positive outcome though, here's a clip of me enjoying to music that I'm not actually hearing. Yeah, you see? It was a positive end. No, I'm just kidding, it wasn't. Bye.